Hello students, welcome to the next chapter of the chemistry ICSE syllabus, Mol Concept and Stoichiometry. First, let me explain you the heading of this chapter, Mol Concept and Stoichiometry. First, what is mole? If you look at the textbook definition of mole, it is the amount of substance which contains the same number of units as the number of units in 12.000 grams of carbon 12 isotope. That is the textbook definition of mole. Now, and then come down to stoichiometry. Stoichiometry. This word stoichiometry, if you look at the word stoichiometry, it looks a very difficult word, but it is not very difficult. The word stoichiometry means the branch or a subject under chemistry where we study the amounts of different substances which are present when a chemical reaction is taking place. Okay, now let me explain you first what is 1 mole or what is mole. Now, let me write down the atomic weights or atomic masses of some elements. For example, if you talk about hydrogen, it is 1. If you talk about carbon, it is 12. If you talk about nitrogen, it is 14. Okay, oxygen, it is 16. These are few elements which I have written down. And these numbers for hydrogen 1, carbon 12, nitrogen 14, oxygen 16 are the atomic weights or atomic masses of these respective elements. So by using these numbers, I am going to explain you the meaning of mole first in this chapter. It is very important for all of us to understand here the meaning of mole. Let us see. For example, if I take hydrogen 1, if I write 1 gram of hydrogen, this is 1 gram of hydrogen. If I write 1 gram of hydrogen, this hydrogen I have written only H over here, means it is an atom. This hydrogen is an atom. 1 gram of hydrogen, it is an atom. So that's why these numbers are called atomic weights or atomic masses. Now, let us go further over here and make some molecules out of these elements. For example, if I combine hydrogen and carbon and make a compound, for example, the compound will be CH4. Here in this case, it will be CH4. This is methane. This is methane. This is methane. CH4 is methane, chemical formula of methane. Let me combine other elements also. For example, if I combine nitrogen and hydrogen, I can prepare NH3. This is ammonia. AMMONIA. If I mix carbon and oxygen, I can prepare carbon dioxide. Carbon dioxide. It is carbon dioxide. Carbon dioxide. I can combine nitrogen and oxygen to prepare nitrogen dioxide also. Nitrogen dioxide also. Now, using these 4 examples, I will try to explain you the meaning of mole and the meaning of mole concept. Now, let us look at methane first. CH4. In methane molecule, there is 1 carbon atom and there are 4 hydrogen atoms. 1 carbon and 4 hydrogen. So, by using the atomic weights or the atomic masses, if I use the atomic masses in this formula, carbon is 1 atom, 1 plus, this is 1 into 12. The atomic mass of carbon is 12. So, I can write 1 atom of carbon into 12 plus hydrogen we have 4 atoms. 4 into atomic weight is 1. So when I add this, we get 12 plus 4. It is 16. So I can write over here G. 16 grams. 16 grams is the molecular mass of methane. 16 grams is the molecular mass of methane. Since I put over here gram, a unit over here, this 16 grams is called gram molecular mass. In short, we write it as GMM. gram molecular mass. The molecular mass expressed in grams is called gram molecular mass. This is the first example. So I have taught you how to calculate the gram molecular mass, and this calculation of gram molecular mass you have very well nicely done in class 8 and 9. Now the second example, the second compound over here is ammonia, NH3. Nitrogen, we have one atom, 1 into the atomic mass is 14, so 14 plus then hydrogen 3 atoms, 3 into 1. So if I simplify this, I will get 14 ones are 14 plus 3 ones are 3, that is coming to 17 grams. 17 grams. Now the gram molecular mass of this ammonia molecule is 17 gram. Now come to the third one, carbon dioxide. Carbon dioxide CO2. The formula is CO2. Carbon 1 atom. Carbon 1. Atomic weight is 12. Plus over here oxygen 2 atoms. 2 into 16. So this I will get 16 to 32 plus 12 is, it comes to 44 grams. So the gram molecular mass of carbon dioxide is 44 grams. Then come to nitrogen dioxide. Nitrogen dioxide, nitrogen 1 atom, so 1 into 14 plus oxygen is 2 atoms, so 2 into 16, so that comes to 16 to the 32, 32, 42, 46, so here it comes to 46 grams. So now please listen very carefully. Here the gram molecular mass of nitrogen dioxide is 46 gram. The gram molecular mass of carbon dioxide is 44 gram. The gram molecular mass of ammonia is 17 gram. The gram molecular mass of methane is 16 gram. So 16 grams of methane is called 1 mole. 16 grams of methane is 1 mole of methane. 1 mole. 1 mole. Now the picture will be very clear over here. 16 grams of methane is 1 mole. If you look at over here ammonia, 17 grams of ammonia is again 1 mole. 1 mole. Again the third one, carbon dioxide. 44 grams of carbon dioxide is again 1 mole. Again, next one is nitrogen dioxide. 46 grams of nitrogen dioxide is 1 mole. So, what we have understood over here? We have understood a very important sentence, very important concept over here. The gram molecular mass of any substance, the gram molecular mass of any substance is equal to 1 mole. So that is what we have to understand over here. You bring any compound, say it is sodium chloride or calcium carbonate or any other compound, sodium sulfate, potassium sulfate, anything you bring, ammonium chloride, by using the respective atomic weights or atomic masses, if we calculate the gram molecular mass, that gram molecular mass of that particular substance is always equal to 1 mole. Okay, now let me explain you what is stoichiometry. Stoichiometry, it is the branch of chemical science or chemistry where we learn about the relationship in terms of ratio in between the reactants or the products which are formed in a chemical reaction. So by using this branch of chemistry, stoichiometry, it is possible for us to calculate so many things, in a chemical reaction. What is the mass of the reactants? What is the mass of the products? By knowing at least one or more of the variables in a chemical reactions. Let us take one example. If I take a chemical reaction, for example, nitrogen gas combining with hydrogen gas to form ammonia gas. This is a gaseous equation. This equation is not balanced. To balance it, I have to put 2 over here. Nitrogen becomes 2, hydrogen becomes 6. So nitrogen is already 2. So hydrogen I have to make 6 this side. So I put 3 over here. Now, in this chemical reaction, if according to stoichiometry, if you try to understand according to stoichiometry, this is a gaseous reaction altogether. So here I will not talk about grams or kilograms of the reactants or products. Here I will talk about the volume, maybe in liters or milliliters. So if I bring 1 liter, say 1 liter, or if I bring 1 milliliter, if I bring 1 milliliter of nitrogen gas and combine it with 3 milliliter of hydrogen gas, then according to this chemical equation, which is balanced, which is what? Balanced, we will get the product 2 milliliters of ammonia gas. Now, let me explain this properly. What is very important to understand over here is 1 milliliter, there is 1 before nitrogen. This number 1, there is 3 milliliter, 3 before hydrogen. There is 2 over here, 2 before ammonia. These numbers 1, 3 and 2, these numbers which are written before the reactants or the products in front of any chemical reaction, they are called stoichiometric coefficients. Stoichiometric, S-T-O-I, stoichiometric coefficients, C-O-E-F-F-I-C-I-E-N-T-S, stoichiometric coefficients. Now, if you look at these numbers very, very carefully, these numbers are whole numbers. They are not fractions. They are neither decimals. That is why such numbers which are whole number ratios, these numbers which are used, which are written before the product or the reactant, they are called stoichiometric coefficients. And the use of these stoichiometric coefficients to find the ratio in volumes or ratio in weights, grams, kilograms of the reactants or products, they are studied under this branch of chemistry, which is called stoichiometry. Now, before moving further in the chapter, first let us understand what is STP or NTP. STP, the word this over here, STP, standard temperature pressure, normal temperature pressure. Okay. Now, these words we have learnt in class 9 also. Now, we talk about at STP. At STP or at NTP. NTP what? Temperature pressure. Temperature pressure. At STP, the temperature is normally 0 degrees Celsius or 273 Kelvin. At STP or NTP, the pressure is 760 millimeter of mercury, or we can write 76 centimeter of mercury, or we can write 1 atmospheric pressure, ATMP. So these are the two values which must be remembered. At STP, the temperature is taken as 0 degrees Celsius or 273 Kelvin. And at STP, the pressure must be remembered as 760 millimeter of mercury or 76 centimeter of mercury or 1 atmospheric pressure. Now, I want to explain you one more thing over here besides STP, now which is called molar volume. Molar volume, the word is called molar volume. Let me explain that word also. It is molar volume. Molar volume, the definition, first the meaning of molar volume. Molar volume, it is the volume occupied by 1 mole of any gas. 1 mole. That time I was talking about mole. So 1 mole. Volume occupied by 1 mole of any gas. Now, here it is very important to understand volume occupied by 1 mole of any gas. It is an incomplete sentence. When? It is very important to know when. What are the conditions? So, if I put something over here, volume occupied by 1 mole of any gas at STP, then I can understand that at STP means the temperature is 273 Kelvin, the pressure is 760 millimeter of mercury or 76 centimeter of mercury or 1 atmospheric pressure. This is something which has to be understood over here, STP. So, whenever this STP comes in this sentence, then this molar volume is called standard. It is called standard. Now, so the standard molar volume, it is the volume occupied by 1 mole of any gas at STP. That means if I take, for example, let me take a gas, say if I take oxygen gas. Oxygen gas, what is the mass of 1 mole of oxygen gas? It becomes 2 into the atomic mass of oxygen is 16. So it comes to 16, 2 is 32 grams. Mass of 1 mole of oxygen gas is 32 grams. So now 32 grams of oxygen gas means 1 mole of oxygen. Now 1 mole of oxygen, which is 32 grams, occupies what volume? And that is a constant for all the gases. So that constant value, 32 grams of oxygen gas, which is 1 mole, occupies a volume of 22.4 liters or 22,400 milliliter, or we can say what you call centimeter cube. Instead of liters, we can also write decimeter cube. Okay, so this is very important to remember. Now, these are the things to be remembered and learned properly and carefully. So, again I repeat once more, standard molar volume. The standard molar volume, it is defined as the volume occupied by 1 mole of any gas at STP. Now, what is STP? At STP means the temperature must be 273 Kelvin and the pressure must be either 760 millimeter of mercury or 76 centimeter mercury or 180 MP. And by an example, oxygen gas, I have taken oxygen gas over here. Atomic mass of oxygen is 16. So in a molecule of oxygen, there are 2 atoms. So 2 into 16 gives me 32 grams. 32 grams of oxygen is the gram molecular mass. So 32 grams of oxygen means 1 mole. So 1 mole of this oxygen gas will occupy a volume of 22.4 liters. This is to be memorized. 22.4 liters is also called as 22.4 decimeter cube, and in the lower unit we can write 22,400 milliliter or 22,400 centimeter cube. Now, what is to be summarized over here? If I bring any gas, nitrogen or ammonia gas or sulfur dioxide gas or any other gas, if you bring 1 mole of any gas from anywhere, that 1 mole of gas at STP will always occupy this volume, either 22.4 liters decimeter cube or 22,400 milliliter or centimeter cube. Okay, now the next thing I will be discussing with you all in my next video will be the main part of this chapter, which is called Gay-Lussac's law. After Gay-Lussac's law, I'll teach you some problem based on Gay-Lussac's law. Then after completing the problem based on Gay-Lussac's law, I'll be teaching you Avogadro's law. I'll be telling you about Avogadro's number, and then numericals based on both Gay-Lussac's law and Avogadro's number. So let us meet in the next video from this chapter, Mol Concept and Stoichiometry. Have a nice day. Thank you.